I would like to warmly welcome you here physically in the Peatland Pavilion at COP26 in Glasgow, and also out there online joining us via our virtual Peatland Pavilion. Today, to the session on the state of peatland knowledge, in which we would like to present you the status of the Global Peatland Assessment and Mapping. So you can be excited about what we will present you today. That's a collaboration of the Global Peatland Assessment Development Team, consisting of the lead of the Global Peatlands Initiative, UN Environment, the FAO, the Greifswald Mire Center, and UNEP WCMC. My name is Jan Peters. I'm the Managing Director of the Michael Zucker Foundation, which is one of the partners in the Greifswald Mire Center. I'm also one of the members of the Global Peatlands Assessment Development Team. First of all, I want to give you a little bit an overview what the Global Peatlands Initiative actually is. The Global Peatlands Initiative is a partnership which works to save peatlands as the world's largest terrestrial organic carbon stock. Next slide. I can do it on my own. At the moment, we have 46 organizations which are collaborating together in all countries to conserve, restore, and sustainably manage peatlands. Through the GPI project, which is supported by the German Ministry of Environment's International Climate Initiative, we directly support 4 tropical peatland countries: Indonesia, the Republic of Congo, the Democratic Republic of Congo, and Peru. We work all around the world with stakeholders to connect practitioners, scientists, investors, and policymakers to facilitate South-South and triangular cooperation and strengthening the partnerships and action towards better practices for peatland management. Together with our partners, we are making progress, and one of the big milestones we achieved in 2019, when at the 4th United Nations Environmental Assembly, resolution dedicated to peatlands was concluded and adopted on the conservation and sustainable management of peatlands. The resolution is committed by all member states in the world to give a greater emphasis to the conservation, sustainable management, and restoration of peatlands worldwide in support of sustainable practices in peatland management. The resolution specifically requests the Executive Director of the United Nations Environmental Programme, within the scope of existing resources and in consultation with the Secretariat of the Ramsar Convention, to coordinate efforts to create a comprehensive and accurate inventory of global peatlands, which will be crucial as a basis for identifying the extent of peatlands globally, determining appropriate interventions, and understanding the value and potential of carbon sequestration and planning for sustainable peatland management. So all countries in the world have, in this resolution, requested UNEP to coordinate these efforts with a comprehensive and accurate global peatland inventory. And to make that happen, with the Global Peatlands Initiative partners, especially FAO, we used the funds of the GPI project to establish a global peatland inventory through a Global Peatlands Assessment, which we will present to you today. The assessment will quantify the carbon storage and current greenhouse gas emissions, as well as identify biodiversity values and other ecosystem services, and will also address plans for sustainable peatland management. This is specifically captured in our priority intervention areas, which will lead us to the ultimate goal of reaching zero emissions from peatland degradation latest by 2050. And with this state of the world's peatlands through the Global Peatlands Assessment, we would like to feed in knowledge and data to make the best policy decisions. We have the hope, intention, and ambitions to have the assessment as a regular and increasingly impactful source of knowledge and information to be used by policymakers and others. The Global Peatland Assessment Development Team, made up of UN Environment, the Greifswald Mire Center, FAO, and UNEP, WCMC, is very excited to present the status of the assessment today. And we are also very happy that we secured a very high-level team of coordinating lead authors for the different chapters which work on a voluntary basis to make this global peatland assessment happen. So we are very grateful for all who have supported us so far and which will support us in the future. And we would very much welcome you to join in to support us for this important flagship product for peatlands. If you would like to have more information on the Global Peatlands Initiative, please contact Diana Kopansky from UN Environment, who I'm replacing today here on the board, as she unfortunately can only join online. And with this, I would like to involve you a little bit here in the audience, but also you online. We already shared for you online, we shared in the chat a link to a Mentimeter, and also you here in the audience, if you have your smartphone ready, you can go to the www.menti.com website, put in the code, and join our little questionnaires here. So we would first like to know from which sector you are here. If you're from governmental organizations, from science and academia, if you're from NGOs, from private sector, from land users, or from other sectors. So far, so we have quite some people from NGOs here in the room and online. We have multilateral intergovernmental organizations. We have governmental and administration. We have science. So we have quite a good share. Others we also have, so probably from land use sector, from other sectors. So it seems that we have quite some good representation also from science here, which is very nice, as this whole approach should be science-based in future. So maybe we go to the next question. From which continent or country are you? Please put your answer in the Menti so that we get an overview from where the audience is connected today. From the UK, of course, as we are here in the UK, in Scotland. Europe, Finland. So a lot in Europe, but now also North America, Colombia, South America. UK is quite strong. From Germany. So we have quite strong representation from Europe, but also a good audience from beyond, from Peru, which is one of our focus countries in the Global Peatlands Initiative, from Nairobi, from Indonesia. So we have quite a good representation of different regions and countries here. Let's go to the next question. How many years have you been working with peatlands already? Less than 5 years, 5 to 10 years, 10 to 20 years, or more than 20 years? So we have quite a lot of newcomers here, the biggest bar. So a lot of people got attention on peatlands in the last years, obviously, but also some which are working already more than 20 years with peatlands. So really experienced people here in the meeting, which is nice to see, of course. Great. Wonderful. Do we have a next question? And just to finalize this little interactive session, I would like to ask you, why do peatlands matter to you? Please keep it very short. put it into the Menti just in 3 words. What comes into your mind immediately? Why peatlands matter to you? No results yet? Yeah, now we have culture, carbon, biodiversity, beauty, wild places, conservation, landscape, research, wildlife, water. This already shows quite well kind of the multi-layered functions of peatlands and why they are such super nature-based solutions which are covering so many different areas and contributing to so many different sustainable development targets. People, unique ecosystem services, people. So very nice representation here in this work cloud we see. So thanks a lot. Thanks a lot for giving us this impression, why you're here, why peatlands matter to you. I think that's a very good start and a very good motivation to get involved with the Global Peatlands Assessment, to know more about it. And I would like to hand over the word to Leora Miles first, who will give us from UNEP WCMC to give us some insights how the assessment is set up, how the methodology works, and how you can get involved. Please, Leora, come here. You don't need the headphones, I think. Can just speak, and with this you click the
lovely
slides. Welcome.
Excellent. I hope you can all hear me okay. It's a real pleasure to be here to introduce the work on the Global Peatlands Assessment that started to get underway on behalf of the Global Peatlands Initiative. And I'm here from the United Nations Environment Programme World Conservation Monitoring Centre, which is helping to coordinate the assessment. First of all, just to remind ourselves, why might it be useful to have a global assessment on peatlands and their status? As we've been hearing throughout the week here in the Peatlands Pavilion, and as you've all just expressed in your feeding in what 3 words illustrate how peatlands matter to you, peatlands are important for a whole variety of reasons, which these days we describe as nature-based solutions, or at least actions to better protect, to better manage, and to restore our peatlands are solutions to deal with societal challenges, which we can call nature-based solutions. So long as, according to the IUCN definition, those things are efficient and adaptive and bring biodiversity and human well-being benefits. So not just any old change in land use for a single objective, but nature-based solutions solve multiple societal challenges. And in terms of climate change mitigation, we've just been undertaking a review of all of the synthesis studies on the potential for different nature-based solutions to contribute to climate change mitigation. And across these studies, actions in peatlands represent about 10% of the potential, which is extraordinary given that peatlands only represent about 3% of the land surface. And the overwhelming majority of that potential is potential on land. Of those, if I remember correctly, about 37% represents the potential to reduce emissions from degraded peatlands. So about 37% is in peatland restoration, and the remainder is in preventing further peatlands from becoming degraded. And this is very much according to global studies that have looked across all solutions rather than studies that are completely focused on peatlands. So we need a global peatlands assessment to bring this kind of information to decision makers to support sound decisions on peatland protection and management worldwide. We hope the Global Peatlands Assessment will do a wide range of things here. So bringing policy relevant information, but also highlighting gaps in our existing knowledge in areas where further research is required. Bringing together the best available science, but also information from other traditional or indigenous knowledge sources. Highlighting the drivers of peatland degradation, but also thinking about examples of success in tackling those drivers and successfully restoring peatlands. And as well as being an information resource, we hope that the process of preparing the assessment itself will generate political momentum for peatland protection, management and restoration, and in doing so help us to tackle the multiple challenges that some of our peatlands face worldwide. The assessment process is inspired by that of the IPBES, which I always get this wrong. The Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. I want to make it sound a bit more like IPCC. Because IPBES assessments aim to bring this kind of policy relevant knowledge to decision makers. We aim to do the same thing for peatlands, highlighting their benefits for nature, people and climate. We want to critically evaluate the scientific knowledge and prepare a synthesis across the latest scientific research. As I mentioned, we also wish to consider different types of knowledge coming from more traditional sources and highlight knowledge gaps, but the assessment itself won't be undertaking any original research. It is an assessment process, not a research project. And it's inspired by that intergovernmental process of the IPBES, but it's not in itself such a formal intergovernmental process. So the process of the Global Peatlands Assessment is intended to have a bit of a lighter touch than that. We've gone through the very first stages of preparing what we're going to be doing in the assessment, building a strategic partnership, as Jan was mentioning, of fabulous organizations who are helping to coordinate the assessment, preparing the concept note and getting all of that evaluated and approved. And now we're starting the assessment process itself. We have an excellent set of coordinating lead authors who've consented to be involved. We have nominations of many potential contributing authors, which the coordinating lead author teams are looking at to make sure we've got a great set of people working on each of the chapters. And then the assessment process will proceed with preparing iterative drafts of the assessment, as you might expect, and a summary for policymakers. That'll be approved following review. Obviously, we need a peer review process. It'll be approved by the Global Peatlands Initiative Steering Committee and in consultation with the stakeholders of the initiative throughout. And then we get into an outreach process to make sure that the results do reach that policy audience. And what's kind of missing from this process is design, because what we're hoping for here is something that's a very beautiful digital first assessment that will be accessible for all kinds of stakeholders. And that's going to be, I think, a really exciting part of the process. We will have a printed summary, but the assessment itself will be primarily presented online. So key elements throughout the assessment process, obviously the content of the assessment needs to be owned by the set of authors, and there needs to be a good interaction between those authors and other stakeholders of the Global Peatlands Initiative. And we want to have regular communication, not just within the chapter groups, but between the chapters to make sure that we're having a good knowledge sharing throughout the process, and that we have transparency and legitimacy throughout the process. Now, as I said, we're right at the beginning of the assessment stage. So we have 30 coordinating lead authors working on, obviously, an introduction, but also global chapters on the extent and status, profiling the best available information on where peatlands can be found and what condition they're in. A global chapter on policy options, but then the heart of the assessment will be these 6 regional chapters covering all the peatland regions of the world. We've had the first coordinating lead authors meeting to discuss the overall content of the report and how the CLAs will be working together. That was at the end of September. So as you can see, we really are just getting started on this assessment process. And the selection of contributing authors to work alongside those CLAs is ongoing, as is the preparation of the very first draft of what the report itself will look like, the zero order draft. And then for the rest of the session here, we're going to mostly hear about the Global Peatland Map, which forms the basis for all of the spatial information in the assessment. So there's been a tremendous amount of work on preparing this global map so far, which we'll hear about in a moment. But we still hope there's an opportunity to improve some of the content of the map, because all of the rich knowledge of the authors of the assessment may bring us some better information at different scales that we can use, particularly in the regional sections. We're also hoping to compare that global map with some of the other global products on soil organic carbon extent, the extent and the quantity of soil organic carbon throughout the world, to try and resolve some of these questions around how much peatland is there and how confident we are in how much peatland there is in different regions. And to get a decent understanding of the pressures on those peatlands and upon the protection status of those peatlands and the value of those peatlands, both in the global and in the regional parts of the assessment, we'll be looking at the peatland map together with other thematic maps, such as species distributions or protected areas or fire. And in using the Global Peatland Map as a basis for the assessment, we know that there are some sorts of challenges that we'll run across, because we're comparing one set of definitions and peatlands worldwide. And we'd love to have consistency throughout the assessment so that every fact about peatlands was coming from the same idea precisely of what peatlands is. But as we'll hear in a moment, there is a diversity of peatland definitions, and different researchers will have used slightly different ideas about peatland. So what's essential is that within the assessment, we're being crystal clear when we present any piece of information about what that peatland definition is that's underlying the information. Where was I? Challenges in the mapping. Well, I think we're going to hear about this in a moment, but clearly, if we have higher resolution regional national maps that are a bit different to what we've seen in the global map, we have some decisions to make about what we want to profile in the regional chapters, particularly if we have better information for part of a region than another. There are going to be issues in some regions, especially when you have very fragmented regions, it's very fragmented peatlands, in getting detailed enough information about the pressures or the values of those peatlands. So what we see in the different chapters might not be identical to one another. There are regional asymmetries in the data that's available. And yes, finally, when we have information from the literature about the status and the extent of peatlands, and we have spatial information that we've prepared from our global analyses, we may find that we're seeing a range of results in terms of what's going on within peatlands in any given region. But these are fairly natural things to come across in such an assessment process. That is my last slide. So we'd like to ensure complete consistency across the assessment, but some compromise is absolutely inevitable. There's no new research, but I hope that we'll have some new findings coming out of this process as we bring together all of this information to create a global synthesis. Thank you very much. Willing to answer any questions later.
Thank you a lot, Lyra, for this very detailed and comprehensive overview of the assessment, where we stand at the moment, how it's going on. I think that's a very, very good opening to the session to know what we are actually talking about. And as you rightly say, we will, after the next speaker, we will have a block of discussion, question and answers. So keep your questions in mind for Lyra. Also online, you can put your questions, please, not in the chat function, but in the Q&A. Then I will see the questions here, and we can discuss after the next speaker, which is Professor Hans Joosten, the Secretary General of the International Mire Conservation Group, the IMCG, and he will shed for us some light on the question, what is a peatland? What are the definitions behind peatlands? and what are the kind of obstacles and challenges we also have to confront when we are talking about a global peatlands assessment, which is really covering a global scale. Please, Hans, the floor is yours.
Yes, we are here in the Peatland Pavilion, and you would almost expect that we would know where we are talking about. But that is exactly the issue. Peat and peatland, what is it? Peat and peatlands is an issue like we have so many issues. As long as you do not ask, everybody knows where he or she is talking about. But if you really go into deep in it, where are we limiting it? That is, and I want to share now with you some considerations that we have in the Global Peatland Assessment with respect to definitions. Peatlands, as you know, are very diverse. They occur across the globe, and they are addressed by a multitude of interests and methodologies, by disciplines, by scientists. And we notice that actually the different disciplines, the different people have different concepts about what they mean when they talk about peatlands and peat. It is not for nothing that the UNFCCC and the IPCC have never dared to come up with a definition of peatlands. The fact is that many countries have their own definitions, but they are not completely compatible. So the question is, what do you have to do in a global assessment with respect to the fact that there are so many terms and also so many different definitions? Of course, with respect to peatlands, we can make it very easy. Peatland is land with peat. And we can restrict it to say, okay, the peat must be at the surface. If it is 10 meters deep, we do not call it a peatland anymore. And actually, the peat should also have accumulated spontaneously. If you go to the horticultural shop and you see a bag of peat laying there in the shop, you do not call it a peatland, although it is land with peat. So peatland is not the issue so much, as long as you do not go into detail. Then we have this concept of peat, whereas peatland is an area, peat is a substance. And this substance consists largely of dead organic matter, actually almost always with macroscopic plant remains that you can still see. And these plant remains have not been relocated by water or ice or wind after their production and death, because otherwise we would call it a sediment, and a sediment is not peat. So if we define these things qualitatively, it is rather simple. But if you want to do statistics, or if you want to make maps, you must give quantitative definitions, and there the problem occurs. If peatland is land with peat, you must ask yourself, how much peat must there be? Is 1 centimeter enough? Or do you have another minimum level? And then you see that there, the different countries and disciplines, and also over time, use different measures. 20 centimeter has been used, 25, 30, 40, 50, 70. And yet you also notice that these definitions have been informed by specifically agriculture. Why is 20, 30, 40 centimeters valid? That has to do with the depth of a plow. If you plow once and everything is mixed up, then you have changed the land. You see it in Germany. In former times they had 20 centimeters, then they had shortly 25, and then it became 30. That was simply the development of the depth of a plow. In Russia, they have a definition of a peatland of 70 centimeters. In Indonesia, of 50 centimeters. 70 centimeters has to do which is economically viable to extract. Yes? So we see that the current definitions that are used in mapping are informed by things like agriculture or peat extractions, actually the things that destroy the peatland. Nowadays, we want to map peatlands from the perspective of climate change mitigation. climate change mitigation. So what does that have for implications for a peatland definition? As Jan and Lera have already expressed, the Paris Agreement actually implies that in 2050 we should have zero carbon dioxide and other greenhouse gas emissions net. And that means that in fact we should protect every layer of peat, even the layer of 1 centimeter thickness. That is not really practical, you can say. Actually, in forestry or in forest protection, we have a similar question. And that is the concept of the high carbon stock forest. Which forest must we protect against deforestation? And there, in deforestation discussions, several numbers have been mentioned. Greenpeace has used 50 tons of carbon in the above ground biomass. Others have used 75 tons of carbon in the above ground biomass. And above this level, it is called a high carbon stock forest, and it should not be cut down. But what applies for carbon in biomass should also apply for carbon in peat, because the climate is not interested where the carbon is coming from. A molecule from forest biomass and a molecule from peat heats the climate in the same way. If you, for example, take as a threshold for high carbon stock forest the 75 tons of carbon, and you compare that with peat, then you must be aware that a typical tropical peatland has a carbon stock of about 6 tons of carbon per centimeter of peat per hectare. That means that a layer of peat of 13 centimeters thickness has already reached the threshold under which we protect a high carbon stock forest. There is no definition of peatland that goes so low as 13 centimeters. There is another issue. So the centimeter stuff is clear. If we compare it with forest, we should at least conserve all peatlands with a layer of peat of 10 to 15 centimeters, this order of magnitude. And then we have the issue of the peat. Peat is, of course, organic matter, but not only organic matter. There is also mineral substances. And then you have to define or think about that, how much organic substance must be in the peat to call it peat. And also there are big differences between countries, sectors, and scientific disciplines. Peat has been defined in scientific literature as having a amount of organic matter of 5% of the dry weight, very low, 15, 30, 50, 60, 65. Where is the threshold actually? And then we touch upon some very interesting issues. This concept of percentage of organic matter in the soil comes from soil science and is also informed by agriculture. Is it suitable for agriculture? But from a climate change point of view, you have to think in another way. If there is sand in your deposit, then you refer to another type of weight. It is actually so that a deposit with 5% of carbon has more carbon per volume than a deposit with 55% of carbon. 55% of carbon, then you have pure organic matter, and the rest is water, but you express it in dry weight percentage. Yeah? Whereas if you have 5% of carbon, you have 95% of your weight determined by sand or by clay, which is 3 or 4 times heavier than organic matter. So 5% of carbon, a soil with 5% of carbon has per cubic meter more carbon density than a soil with 55% of carbon, and has upon drainage also larger emissions. That is contra-intuitive, but it is the heritage that we have of soil science. And actually, if you look at the official definitions, where the boundaries between mineral soils and organic soils, it is at 18% of carbon. And that is exactly the place where there is the highest density of carbon. So we have to put the boundary on the place where is the most carbon. So that is a little bit stupid. So actually, from a climate point of view, we should define organic soils starting with 3% of carbon, not with 18% of carbon. So these are the complications we are fighting with. From a climate point of view, you could take a peatland definition comprising all areas with more than 15 centimeters of peat, and with peat having more than 5% of carbon, to round off the figures. Of course, this has large consequences for the mapping, but it would also cover important wetland types marginal to the really peatlands, sensu stricto, like papyrus swamps, dambos in the savannas, cloud forest, various coastal mangroves, etc., etc. So we have to sort out, do we include these things in our concepts of peat in the Global Peatland Assessment? The other thing is how you detect it. Of course, these shallow peats do not influence the vegetation in the same extent as if you have a very thick peat. And of course, for normal reconnaissance mapping, if you go to areas where you do not know anything, that are hardly accessible like peatlands always are, then you have to rely on remote sensing. But you will not find these shallow peatlands that are relevant for climate. But you have to do it to find a coarse distribution of peatlands that you can use for planning purposes. But if you really go into the field trying to change the peatland, then you have to look really on the ground in the soil. So these are some of the considerations with which we are now a little bit struggling. Thank you.
Yeah, thank you, Hans, for making us aware of all these complications, all these challenges we have to face, and some of them even counterintuitive. I think a lot of food for thoughts for our future work on the assessment. And now I would like to go into a next round of the Mentimeter. We have some more questions after you got to know a little bit from Lira what we are actually dealing about in this assessment. We would really like to know how we could better how we can use the assessment in order to better include peatlands into climate action in your country. How important are the following points? So please tick some of the points in the questionnaire so that we can see how important things like peatland maps, peatland monitoring, peatland conservation, developing of alternative sustainable livelihoods, finance mechanism, collaborative intersectoral networks, inclusion of peatlands and policy in legal mechanisms are. And we see that, peatland conservation is quite high on the agenda for you. Developing alternative livelihoods, very important. And also, only one person. Oh, I couldn't see it there. So for one person, that's very important. Now it's changing a bit, but peatland conservation stays important. And we see that financial mechanisms, which we discussed actually last week, are not so high here on the agenda. It's more about mapping, conservation, livelihood options, and policies, of course, policies and legal mechanisms. Okay, thank you. Then we switch to the next question, please. What do you or what would you particularly like to see featured in the assessment? Please rank that according to your preference. So is it the peatland distribution and status? Are these the scientific findings, land use change and hotspots of degradation, policy recommendations, multiple values of peatlands, or knowledge gaps of mapping and research? I'm really excited what you are choosing here. So first is peatland distribution status, scientific findings, quite high on the agenda, but we have also seen that we have quite a lot of participants from the scientific community here. Land use issues. Policy recommendations are not so high here, although we have seen that policy and legal instruments were high on the needs assessment. So now it's getting up and down. But peatland distribution and status is definitely one of the things which we really want to see featured in the assessment. And I think that's a very good link to our next speaker, which I would like to invite now. This is, I think we will skip the last question, and I would like to move over to the next speaker, which is Alexandra Barthelmess from the University of Greifswald, a partner in the Greifswald Mire Center, who is coordinating the Global Peatland database, and she will tell us a little bit more about the fabulous map we have already seen in front of the pavilion here. Unfortunately, she is only here with us virtually, but Alexandra, the floor is yours to explain us more about this map and how you work about peatland distribution, as this is very high on the agenda of the participants here. Please.
Sorry for that. I get to go. So, yes, sorry for having some challenges here, but thank you, Jan, for introducing me, and good afternoon from Greifswald to Glasgow. Thanks for the opportunity to present some of our work that we have conducted under the Global Peatland database. Doug. Okay, here we go. But no. So the Global Peatland Map has some long-term background. The Global Peatland database, and Hans Josten, the most of this that has most done this, started to collect data on peatlands in the 1990s, and this has been started at project of the International Mire Conservation Group. Since 2012, we have had some change and concentrated more on the collation of spatial data, and we have started there to collect spatial data for the Global Peatland Map. And this work especially got accelerated, this mapping and collating of spatial data through the Global Peatland Initiative project, on which we are running this year and next year. One of the project tasks has been to develop a more comprehensive and exact global peatland map. Now I would like to share some thoughts of mine on peatland mapping, something that I started to call a kind of peatland mapping cascade. Recognizing that the kind of peatland mapping depends on the available funding, the purpose of mapping, the targeted scale, the methodological skills of the mapper, and available funding and time frame. So if you're on a scale from very high resolution on top of the blue arrow to very low resolution on top of the blue arrow, go to very high resolution in the bottom of this blue arrow, you can have different approaches that you can need, and you have to choose. So if you do not know and do not have no peatland information available, and the location of potential peatlands is highly unclear for a large area, we developed something that we call the probability mapping using proxy data. So we're using multiple proxies that point at long-term water saturated conditions, and did some overlay analysis and weighting of the data we have used. And here, this map then indicates you the potential regions with peatlands on national scale. For example, you have here a map that my colleague Christina Malpica has been doing, the peatland probability map for Venezuela. If you have a vague spatial peatland information available, then you can use various remote sensing approaches, while increasingly also applying machine learning is applied. Then if you know that peatlands are in the region and you have rather good knowledge, but you need high resolution maps for land use planning, then you, as Hans also pointed out, you have to go back into the field, but you can use also up-to-date GIS-based tools and models, and often then you need manually to delineate peatlands. So this delineates peatland borders on local scale. What we sometimes are also doing is just combining the landscape and peatland ecological knowledge that we have to integrate data and to delineate peatlands, this expert-based manual mapping, and this we apply, you can apply on every scale. All these approaches and the resulting data feeds into the map. The Global Peatland Map has some aims. So we like to cover all important peatland regions globally with some focus on subtropics and tropics and the Southern Hemisphere. We would like to check data sets on its accuracy and completeness if we have get it from external sources. And we would like our aim is to maintain a high level of transparency by supplementary maps and extensive metadata. The coverage of the map is quite inclusive, so it's a composite map showing global peatlands, but also organic soils and suitable proxy data if we do not have peat or organic soil data available. So we use a kind of generic peatland definition. We include data from all scales. We have mainly polygon data, but also included some raster and some point data. And we have a lot of external data from peatland research that has been conducted elsewhere in the peatland scientific community. And we have some own data that we have developed at the Greifswald Mire Center. And here you just see one glimpse on the legacy and digital maps that we have assessed for the Ivory Coast peatlands. So what we have learned during this exercise is that we have some advances of using regional and legacy data because they have often been ground surveyed during field missions in the past. The regional classification is capable to address local and regional specifics of peatlands, and they have often a higher resolution, and thus do not miss small peatlands that can sum up to considerable areas. And here you have one example for high resolution map at the eastern coast of Madagascar showing peat soils and what we can recognize on the satellite image. So one hot topic is, of course, the validation. So the external data that we get from peatland and soil science has often been validated in the respective studies or has been subject to extensive field service. We did some own validation excursions in Uganda and Tanzania, and also in some places in the Caribbean. And this revealed that the most of the areas we suspected to be peatlands are peatlands or covered by organic soils. And what we have also extensively started is the collation of independent peat point data from various sources at GMC. And of course, we would like to have feedback from the GPR authors during the next months. So this is the current state of the map as it is so far, and this is also hanging at the Peatland Pavilion where you are. And just to give some information, so the peatland indication, what have we included here? You see in green that on the map, the peat and peatland data we have included are really dominating, but we have also a lot of organic soils and histosols included in the map on the global scale. This is the region, the Caribbean, where we have more dominating the proxy data, in this case, ecosystem, vegetation, and high probability maps. And now to the sources of the peatland data. As I've also mentioned before, we have some external data and we have GMC data. And you see on red and orange and yellow, the external data that is included. And this is on a global scale, again, largely dominating. And with green, blue, and violet, we have the GMC mapping results, which are, in case of the expert-based digital mapping, dominating in Central and Southern Africa of the map. So far, the Global Peatland Map identifies global peatland distribution more comprehensive. It includes many areas in the subtropics and tropics on mid and high resolution to point at widespread small peatlands. But for comprehensive coverage, extensive mapping efforts are needed in many countries. But also improvements in several peatland-rich northern countries are also needed to consolidate existing maps and data. Here I show you the example for Eurasia, where are some regions quite similarly covered, for example, here in Western Siberia. When we look to other global peatland and organic soil maps. But some regions are exhibiting major differences across the available global data sets, as you can see here. And this is if this happens if we overlay all the data in the ranking that you can see there. So the Xu et al. Map is on top, and then the global soil organic carbon is the most down peatland indication, and it looks a bit like a abstract painting, but it's Eurasia. And this points, of course, and I'm really curious how we will solve it to bring this together and to decide where is really peatland and where not. But there will be some help. Then this global peatland map will be developed further during the Global Peatlands Assessment process. And we really looking forward also to the feedback and the input from the authors to work with them together. This is also a good moment for me to say thanks to the GPT mapping team, and also thank you for listening. And I'm looking forward to collaboration on global peatlands and also for questions. Thank you.
The applause is yours, Alex, and thanks a lot to taking us to the art of peatland mapping and also guiding us through what is all behind this incredible detailed map, which is hanging outside of this pavilion here. So if you want to have a look later, a closer look than here on the small screen, go in front of the pavilion and have a look where peatlands are located worldwide. And as we not only want to look on the global scale, as we have done so far, I would like to ask the next speaker on this panel, which is Jean-Jacques Bambouta, the National Coordinator and Focal Points for Peatlands of the Ministry for Environment and Sustainable Development in the Democratic Republic of Congo, which is one of the honorable countries collaborating with us in the Global Peatlands Initiative. And you will show us something about the peatlands in the Democratic Republic of Congo in the Congo Basin. Please, the floor is yours, and you already have a wonderful hat on for the peatlands.
Thank you, sir. Ladies and gentlemen, good afternoon. I'm Jean-Jacques Bambouta from the Ministry of Environment and Sustainable Development. I'm in charge of peatland in DRC. Only for this day, this is my third presentation. I have again one. So since the COP have begun, this is my the last one will be let's say my fifth of presentation. It seems that some of information that I can share with the slide, maybe you have already seen them. This is why I will just choose some of information that can be, let's say, important for you. Unfortunately, my presentation is in French. As I was saying during the morning, you have also to improve your French as I'm improving my English. Okay. Maintenant, après avoir fait ce bluff, je retourne au français. Je vois les gens en train de me regarder, en train de se dire « Ah, this guy is a crazy guy. » Ok, merci. Bon, et donc, je voudrais partager avec vous quelques informations sur une question. Est-il possible de simplifier la cartographie des tourbières? En ce sens que si on n'a pas suffisamment de budget, si on n'a pas beaucoup de temps, si on a un support en termes des informations qui nous viennent de télédétection, est-il possible de simplifier la cartographie des tourbières? Parce que, comme vous l'avez vu avec la précédente présentation, nous, en République démocratique du Congo, nous sommes conscients du fait que nos tourbières ne sont pas que dans la zone qui a actuellement déjà été cartographiée et identifiée. Donc, nous avons le devoir d'aller aussi dans d'autres zones et de regarder. Peut-être que nous n'avons pas qu'une seule typologie de tourbières. Donc, tout ça, les études à venir vont nous préciser. Donc, voilà une petite étude qui a été menée dans le cadre d'un petit projet qu'on appelait le projet global, qui est piloté par l'Initiative mondiale sur les tourbières, avec une agence d'exécution qui est le FAO. Donc, ont participé à cette petite intervention quelques acteurs du ministère de l'Environnement au niveau national et au niveau provincial. En fait, au regard de la situation de Covid, le petit projet avait deux volets d'intervention. Le premier volet, c'est le renforcement de capacités en ligne sur la cartographie. Alors, des sessions ont été organisées à l'intention des acteurs du ministère de l'Environnement, non seulement au niveau national, mais aussi au niveau provincial. Donc, des gens ont été capacités sur ce qu'on appelle tourbière, sur ce qu'on appelle, sur la façon dont il convient de mener la cartographie des tourbières. Maintenant, le deuxième volet, c'est qu'il fallait maintenant sélectionner quelques équipes pour aller sur le terrain à base des images qui ont été fournies par nos collègues de Congo Pit que je vois ici et bien d'autres que je vais citer. Maintenant, ces équipes-là sont allées sur le terrain vérifier si les données qui ont été codifiées sur les cartes sont effectivement des tourbières. Donc, en gros, c'était celui-là l'exercice que nous avons mené. Let's move. Ça, ce sont les informations sur le contexte de développement de la gestion des tourbières en République démocratique du Congo. J'en ai déjà parlé, je ne vais pas à ce stade en parler parce que dans les prochaines présentations, nous allons revenir là-dessus. Sauf que peut-être l'élément que je peux souligner ici, c'est le renforcement des capacités qui a commencé en 2021 et qui se poursuit. Comme nous parlons de tourbières qui est une thématique, j'allais dire, émergente, on a besoin des connaissances. Mais pour cela, le renforcement des capacités est un volet très important. On peut, Alors, j'avais dit ici ce matin que notre problématique en République démocratique du Congo autour de la question des tourbières est essentiellement articulée autour de la cartographie. Où se trouvent ces tourbières, qu'est-ce qu'elles représentent et quels seraient les itinéraires en termes de valorisation. Et pour cela, nous avons défini une vision qui est protéger les tourbières pour le peuple et pour la nature. Parce que nous pensons que les tourbières, comme je l'ai écrit sur ma tête, sont une superbe solution basée sur la nature. Et pour cela, il va falloir que nous puissions le faire au travers d'une politique nationale dédiée à cet écosystème. Bon, maintenant, en termes de contribution à la stratégie des tourbières, comme je le disais, nous nous sommes dit qu'il va falloir d'abord identifier les informations fiables et adaptées par rapport à la résolution. Un autre élément, c'était pour nous, est-ce qu'en un temps record, il y a moyen de procéder à une cartographie d'une zone donnée lorsqu'on sait qu'on a un petit budget qui est complètement tout à fait limité. L'avantage de cette intervention, c'est qu'il y a eu des parties prenantes de différents niveaux qui sont intervenus pour pouvoir mener cet exercice sur le terrain. Alors, nous avons ici des équipes du ministère de l'Environnement au niveau national, mais aussi au niveau provincial, qui ont participé à cet exercice de renforcement des capacités sur la cartographie dans ce qu'on appelle en République démocratique du Congo le jardin botanique de Yala. Alors, pourquoi ce jardin botanique? Parce qu'il s'agit en fait d'un vieux jardin qui a été créé en 1900, mais dans lequel nous avons à peu près 371 hectares, dans lesquels nous avons 50 hectares de marécage. Alors, nous étions en train de soupçonner que dans ces 50 hectares de marécage, il se pourrait qu'il y ait des tourbières. D'où l'importance de pouvoir mener cet exercice. Alors, ont participé, comme je le disais, les acteurs du ministère de l'Environnement, la coordination provinciale de l'environnement, parce que, comme vous le savez, l'architecture de l'administration en République démocratique du Congo veut que les mêmes institutions que nous avons au niveau national soient aussi représentées au niveau provincial. Et donc, nous avons aussi eu la participation de nos collègues de FAO et nos amis de US Forest Service dans leur programme SWAMP, et aussi quelques acteurs de Fonds mondial pour la nature. Maintenant, en termes de développement de méthodologie, en fait, l'exercice consistait à identifier des types appropriés de couverture de sol. En ce sens que, est-ce qu'il existe des activités qui sont menées dans cette zone qui peuvent à la fois porter atteinte à l'intégrité physique des tourbières? Et quelles sont les ténures de terre qui sont possibles dans ces zones-là? Ce sont ce genre d'informations que nous avons regardées sur le terrain. Alors, on a donc essayé de regarder les types d'occupation du sol, en commençant par le sol préliminaire, et puis on est allé vers une interprétation visuelle. Donc, on commence d'abord par les cartes, mais on amène maintenant cette intervention visuelle sur le terrain pour voir si les zones telles qu'elles sont ciblées sur les cartes correspondent effectivement à l'écosystème qui nous intéresse, oui ou non. Alors, donc comme je le disais, à l'aide des cartes qui nous ont été produites par l'université Leeds, dont nous avons le professeur Simon Lewis qui est dans la salle, mais aussi d'autres cartes qui sont venues de nos collègues de CIFOR, nous sommes allés sur le terrain pour voir un peu comment est-ce que ces espaces se présentent sur le terrain. Quelle est leur dispersion par rapport aux informations qui sont mentionnées sur les cartes. Bon, effectivement, on a aussi utilisé des informations qui sont un peu d'accès libre, mais surtout, nous nous sommes focalisés sur les données qui nous ont été fournies. Et donc, on a traversé plusieurs zones avec des occupations de sol aussi diversifiées, parce que comme j'ai mentionné au début, le jardin Eyala se trouve dans les milieux périurbains d'une zone, j'allais dire urbaine, qui est la ville de Mbandaka. Et donc, forcément, les communautés qui sont les populations qui sont dans la ville partent dans ces milieux mis en défense pour pouvoir pratiquer un peu de l'agriculture, mais aussi pour pouvoir couper le bois en termes de bois de chauffe. Or, nous savons que lorsque dans ce genre d'écosystème, le bois est attaqué, il y a forcément des fluctuations au niveau de la pluviométrie, ce qui pose problème au niveau de l'hydrologie même, qui peut porter atteinte à l'intégrité physique des tourbières. Donc, on peut évoluer. Maintenant, à partir de ce qui a été dit, nous avons ciblé un certain nombre de questions en termes d'éléments de réflexion. Par exemple, comment la méthodologie de cartographie rapide de l'occupation du sol a-t-elle fonctionné par rapport à la carte finale validée sur les terrains? En sens qu'il existe de différents usages de terre dans ces milieux-là. Maintenant, comment la réalité de terrain correspond pratiquement ou pas à la réalité qui a été décrite sur les cartes que nous avons reçues. Donc, on s'est posé ce genre d'informations. Notamment, on s'est aussi demandé comment avons-nous pris sur qu'est-ce que nous avons appris sur les classes d'occupation de sol le plus susceptibles d'avoir de la tourbe. C'est-à-dire que quand on est allé sur le terrain, on s'est rendu compte que certains espaces que nous pensions être de la tourbe n'étaient pas forcément de la tourbe. Et d'autres que l'on pensait que là, il n'y avait pas une tourbière, et là, il y en avait. Donc, c'était ce genre d'informations qui nous ont beaucoup intéressés. On peut aller au prochain slide. Non, on peut. Maintenant, en termes donc de messages clés, nous nous sommes dit que oui, effectivement, il est possible de pouvoir procéder à une cartographie rapide, mais avec un petit budget limité. Mais pour ce faire, il va falloir passer par un important renforcement des capacités des acteurs qui vont aller surtout sur le terrain. Parce que nous parlons de ces milieux, mais en réalité, le professeur Simon Lewis peut témoigner, ce sont des milieux d'accès hyper difficiles, où de fois vous avez du mal à évoluer. Mais nous pensons que ce genre d'exercice peut être dupliqué. C'est comme ça que nous, ministère de l'Environnement, nous remercions donc nos collègues de FAO et de bien d'autres, notamment US Forest Service, qui sont intervenus dans ce genre d'exercice que nous avons trouvé très important. Je dis, je vous remercie.
Merci beaucoup, Jean-Jacques, pour cette présentation très énergique et très intéressante. Et je pense que nous avons appris beaucoup de nouvelles choses de la tourbière de Congo. Merci beaucoup. And I would like to switch then back to English. We now have some time for question and answers. And I would like first to look around here in the room if there are any questions from the audience here in the Peatland Pavilion. Yeah, please, Rob. You get a microphone from the colleagues? Can they take? Yeah. Please.
Hi, Rob Stoneman, Director of Landscape Recovery at the Wildlife Trust. A question for Hans, really, on this issue of shallow peat. I thought that amazing stat around 13 centimeters is equivalent to high stock forests. If we were to map 13 centimeter peatlands, actually that would be quite difficult, but if we were, do you have a feel for how much that would expand the peatlands area across the globe?
Is it on? Yes, yes. Yeah, we have an idea because some countries have done that. For example, Russia has systematically mapped their PT soils that have less than 30 centimeters of peat. And they have also been included in maps. And for example, also Finland has done that. Actually, Finland has this suo concept that is not really defined on the thickness of peat, but they also have peat suos. So from there we can get the idea how much the peatland area would expand if you would expand from 30 centimeters to 10 centimeters or something like that. And that is then in the order of magnitude of 40% or even doubling in these countries. Yes, it will of course differ from country to country.
Okay, thank you. Then I have from the audience online, I have a question here to Alexandra. The question is, what are the next steps? How do you want to advance the peatland assessment so that the peatland conditions also could be signaled on the peatland, the global peatland map?
Yeah, for sure. I can just say what I have in mind because I'm not really in charge of the Global Peatland Assessment, so I'm part of the development team, but I can only say what I'm thinking. So we will overlay this map with diverse available data on global and continental scale on threats and impacts to the peatlands. And of course, we probably need to zoom in to some areas for cover for getting the higher resolution areas also in some examples overlaid with land use data. Yeah, this is my vision of that. But maybe Lyra will also answer.
Maybe Lyra, you can complement.
So just to chip in that there are some global data sets that we could use, or even pan-tropical data sets that will give us an idea of things like land cover change, which you can compare with peatland extent, but also regionally, the intention is that each regional chapter will be thinking about the pressures that are most prevalent in that area. So we're very much relying on the author teams to emphasize what they would like to show and in terms of what the most important pressures are in each region. So personally, I'm quite keen on bringing in some fire maps, but any maps of drainage, for example, would be wonderful contribution.
Okay, thank you. Then I have here one question from the online audience to Jean-Jacques, which is, I will tell it in French to you. Comment voyez-vous les possibilités d'utilisation de cette nouvelle carte tourbière en RDC? And so how do you see the possibilities to use the new DRC peatland map?
Comme je le dirai dans la prochaine présentation, malheureusement, qui concerne le programme Global Peat, pour nous, la science, la technologie, la cartographie et tout ce qui va avec n'ont d'importance que dans la mesure où cela informe la politique nationale de tourbière. Donc, si nous avons une carte, il va falloir que nous puissions l'utiliser pour voir, par exemple, quelles sont les zones dans lesquelles nous devons vraiment prêter attention en termes de politique. Par exemple, s'il y a des zones de forte pression, il va falloir que notre politique se concentre dans ces zones-là afin de pouvoir éviter les dangers qui feront en sorte que les tourbières soient attaquées ou détruites tout en réduisant leur fonctionnalité écologique. Donc, nous pensons qu'il est important que nous puissions avoir des cartes, il est important que nous puissions les utiliser, mais au même moment, il se pourrait que les informations actuelles qui nous parviennent de la science puissent changer dans les années qui viennent. Et là, nous allons nous adapter à la donne nouvelle. Mais nous pensons que la cartographie sera en effet utilisée dans l'élaboration de la politique nationale de tourbière parce que c'est notre élément fondamental. Comme je commençais par le dire, notre première préoccupation est celle de savoir où sont exactement les tourbières de la RDC. Voilà, mesdames et messieurs, ce que je peux dire.
Merci beaucoup. Thank you very much. Then I have one question here for Lyra. Assessment is often used to describe the status of peatlands, so if they are degraded, pristine, whatever. Will this be also part of the assessment, and how detailed will the information be which we can expect from the assessment?
So this is a little bit similar to the previous question.
Yeah.
I guess what's really important is to emphasize that the level of detail will be dependent on the data that we have for every region. So for the Congo Basin peatlands, for example, we know that they're very intact, but as I think we're going to hear in the next session, an understanding of whether they are in fact being degraded at the edges, we're right at the beginning of that. And there is analysis which probably won't have happened by the time we're able to compile everything into the assessment report. So we will do our very best.
So the assessment will definitely, and you mentioned that in your presentation, also be about gaps and new knowledge which we need to really assess globally the status of peatlands.
We very much want to highlight those areas that we're confident in and those areas which are priorities for research. Sure.
But the more people contribute that from all over the world, the better the result is, right?
Indeed. Please get in touch.
Perfect. Are there any other questions from the audience? Yes, please, in the yellow jacket, the lady.
Hi, regarding the mapping, are you also going to be presenting any uncertainty in the distribution maps? So obviously the amount you're saying it's going to be based on remote sensing data, and you also have some peatland point data. Obviously the quantity and quality of data in different parts of the world is quite variable. I work in Peruvian peatlands. I know that in Peru we're getting more and more data, but it's probably nowhere near the volume of data you have available for some of the temperate regions. So I wonder if that distribution map is going to be coupled with a map that also shows either likelihood or uncertainty in the actual mapping output.
Alex, I think this is a question for you.
Yeah, so I'm already was thinking about, so for the data sets that we have from extern, we probably can figure out which is the uncertainty on the mapping results we have from external data, from other mappers, from other research. For the things we are doing, so I'm also, especially in the tropics and the southern hemisphere, it is for me also sometimes kind of indicative to maps. So I think that not any of these areas there probably will be peatland, but most of them, I guess. And I really encourage and invite the people to prove also the audience here and the people to which we reach out via this presentation here, via this session. If you have other data, if you can confirm, or if you can say no, there is no peatland to this area, we are very, very keen to increase the validation efforts we are doing. And this is also why we have started to collate point data that we do not have used so far for the mapping itself, so that it is independently, and that we then have a kind of overall uncertainty that we can address via this point data set, hopefully also during the GPR assessment, the Global Peatland Assessment duration, so that we can include that.
Okay, thank you. Thanks a lot. Please, I would just remind you from the online audience to ask more questions so that I have a bigger choice here for the next questions. But first, I would like to ask Simon Lewis to ask his question.
Hi, I just wanted to hear a little bit more about, for many peatland areas, you have multiple maps available that are often quite different from one another. And how is the peatland assessment going to either combine those maps or choose one of them as the best one for that region? And what happens if that map is not the best one for another region?
Maybe that's a question for Hans or for Alex, yeah? So first Alex, and then Hans can contribute.
What I want to say is that we have also to develop an idea on that during the GPR assessment, and also with together with the lead authors and the authors that give their input to this decision. I think we need to develop to elaborate on this in the GPR process. What we are doing here is also to check on satellite images, but this is of course kind of a subjective measure. But if there are really big mistakes in peatland coverage, you can also detect them in looking on the peatland on the satellite imagery. And the other thing is a process that we have to go through during the GPA. Hans?
Yeah, I do not exactly know what you have been doing, but as far as I have been following it, there is a kind of probability range in the data. So the confirmed peatlands are the peatlands where you have really ground truthing data on a detailed scale. Then the next level of probability is where you have individual ground truthing data, single points, for example, like has been collected by paleoecologists who core everywhere but not systematically. And if you have a point and you can use this point to extrapolate a remote sensing signal in a logical framework, also related to relief and etc., and then it's the next probability level. If you then have other areas where you do not have the confirmation point but a similar signature in the same region, then you come on the next level. So there are several levels of probability. The original data, as I started in the 1990s, I have always used a 5-point scale of reliability. How good are the data on the basis of, for example, the detail of ground truthing mapping? You should not underestimate how much maps have been made also in tropical countries, for example, by the colonialists, who were, of course, interested in how they could exploit the areas as best as possible. Of course, peatland areas are often not the most interesting. And you see that the level of detail stops where the peatland starts, but also, for example, between countries, that when you are in the same valley, that you have different intensities of conformation. But you can, of course, to some extent interpolate also between these things. So it is not a very quantifiable approach, but on a quality level, you can say rather fairly whether which kind of probability it has, I think. But that is also for us a consideration when we have areas where we have indications, a good chance of peatlands occurring, but we have no confirmation. And we try to find people who can go there in the framework of visits and take also single points when they are simply in the surroundings to confirm these observations.
Yeah, thanks a lot, Hans. So ground truthing is still very important to really confirm peatland distribution in the countries. And I would like to ask another question to Jean-Jacques en français. Je voudrais demander une autre question à toi. Sur votre avis personnel, quelle priorité tu vois pour la RDC en termes de cartographie de tourbières et d'évaluation de l'état des tourbières?
Bon, en termes de priorité, je venais de les dire, notre priorité, c'est de cartographier toutes les tourbières là où elles sont. Comme l'a dit le professeur Simon Lewis, nous sommes en train de recevoir plusieurs cartes. Et moi, en tant que celui qui est habilité à pouvoir éclairer le ministre, à pouvoir prendre une décision sur les tourbières, il faut que je sache laquelle des cartes est très importante, laquelle des cartes donne des mesures exactes, laquelle des cartes a des insuffisances. Vous voyez que tout cela, ça peut nous embrouiller. C'est comme ça qu'on a besoin quand même que les collègues qui travaillent dans la cartographie, qui puissent d'abord harmoniser leur propre méthodologie. Par exemple, là, ce matin, nous avons vu la carte qui a été projetée par nos amis de la JICA. Si vous regardez la carte du professeur Simon, vous allez sentir qu'il y a des différences. Vous voyez que moi, en tant que celui qui a l'opportunité de pouvoir prendre une décision politique sur cette matière-là, là, je suis un peu embrouillé. C'est comme ça que donc, il est important quand même que nous puissions avoir une carte globale. Ça, c'est une des premières priorités. La deuxième, c'est de faire en sorte que, une fois qu'on a la cartographie globale, qu'il y ait une bonne politique de conservation de ces tourbières-là. Parce que les menaces peuvent venir à la fois des communautés qui peuvent attaquer l'écosystème en termes de production de moyens de subsistance, mais les menaces peuvent aussi venir d'une mauvaise décision politique. Et donc, par exemple, si je suis celui qui accorde des concessions et que je donne une concession dans une zone où il y a des tourbières, vous voyez que là, il y a déjà des soucis. Donc, pour me résumer, il est important que l'on sache où se trouve cet écosystème, mais il est aussi important que l'on sache si nous pouvons, oui ou non, avoir une bonne politique de conservation et j'allais ajouter de valorisation. Parce qu'en République démocratique du Congo, le politique accorde beaucoup d'importance à la valorisation des tourbières parce que l'aspect conservation ne pose pas de problème pour l'instant. Merci beaucoup.
Cool, thanks a lot. Yeah, valorization is very important for all of us, I think, not only in DRC, but also worldwide. Are there any other questions here from the audience in the Peatland Pavilion? I don't see any. Then I would like to ask Lira another question. Coming back to the issues which Hans raised in his presentation. So how do you want to tackle, or how does the Global Peatland Assessment team will tackle these peatland definition challenges throughout the work on the Global Peatlands Assessment?
I think Hans gave an amazing and very detailed explanation of some of the definitional challenges. And essentially, we know that we cannot rely on everybody using one definition from the literature. We don't want to start generating a new definition for the Global Peatlands Initiative of peatland, but we do need to make sure that whenever we're interrogating a particular kind of a question, such as climate change mitigation, we're using the data that is most relevant to that question, which may use slightly different definitions to thinking about habitats relevant for peatland-loving species, for example. So this isn't one precise answer. We need to draw on the literature that is most relevant to the policy question that that part of the assessment is addressing.
Yeah, thanks a lot for this clarification. I mean, there's still a lot of questions to be answered, but Hans has some more views on that.
Yeah, I think it differs a lot where we are talking about when we are talking about non-exploited peatlands. And if we adopt this way of thinking that we should at least try to protect also shallow peatlands, then you actually only have to know whether there is peat in the uppermost few decimeters. Of course, it is very interesting to know how deep a peatland is and how much total gigatons of carbon there is. But if a layer of 15 or 20 or 30, whatever you choose, is already prohibiting exploitation, and then you can do it in a very quick job. And for example, the progressive palm oil industry has indeed accepted no peat. This 15 centimeters argument we have developed for the palm oil industry, who ask us to map or to indicate areas where they could expand with palm oil without frustrating carbon for the climate in Southeast Asia and West Africa. And they were convinced by this argument. If we accept the concept of high carbon stock forest, we must also concept, and therefore this slogan, no deforestation, no peat and no exploitation, has been arisen in the palm oil industry. So if we can keep this destructive activities from areas from 15 centimeters of peat, we also keep them out of areas with 5 meters of peat or 15 meters of peat. And that is sufficient for the time being. We should try to clear where the risks are and try to avoid the risks over there. So that I think we can do that rather quickly on this scale. Yes.
Thank you, Hans. And as the time is running and we are very close to the end of the session, I would really like to thank all the speakers here and also Alex on the screen for joining us, to giving us these insights into the Global Peatlands Assessment, into the status where we stand at the moment, and also of all the challenges ahead of us. I mean, there's still a lot of work to be done, but I think that we are well set to do that. And I can just reconfirm what Lira already said in her presentation, that all of you are very welcome to guide us on this way, to contribute to the assessment, to be with us, to support us in this big task, and also make it not a singular question or a singular mission, but that let's come to a point where we not only have a peatland pavilion here at the COP, but we also have a regular peatland assessment in which we can then see how peatlands, how the status of peatlands, how land use is developing on our world, and what we can do, what kind of policy solutions are there to actually tackle these challenges we have. And this is, I think, one of the key products of the Global Peatlands Initiative, to really inform policymakers, practitioners, scientists, but also on the national level, the people who are dealing with the peatlands, what is going on elsewhere, how others are kind of approaching the issues, and learn from each other and really benefit from the approach of the Global Peatlands Assessment of the South-South and also triangular cooperation and exchange. So I think this was a very good intermediate step towards that, and I hope that at the next COP we will have the final results, and that we can present you not only the updated map but also the final peatland assessment. And I hope that all of you will stay with us on the way and help and guide us. So thanks a lot. Thanks a lot for the organizers of the Peatland Pavilion, to the tech team who did an excellent job again, and all the people outside there in the World Wide Web following us and getting involved here with the Mentimeter and the questions you put. Thanks a lot, and have a great evening or good day wherever you are. Thank you.